I've been at AWS for approximately 2 years. My previous role was as CTO of ATP Media, so think tennis. 64 tournaments, thousands of matches every year. And my role really was to drive tennis, its technology across data, production, distribution services globally for what we did on the ATP Tour. And prior to that, I worked at IMG. And in both cases, my world has touched on the world of betting. From an IMG perspective, back in the days, I was getting harassed by a lot of the production guys. I was running IMG. I then built Stockley Park. But I was getting harassed by a lot of production people who were saying that they were having a terrible time with the corporate network trying to upload content. And so I ended up walking around floors and various things looking for why that reason might be. And I found a young gentleman in a very dark corner in McCormack House with about 10 laptops running all at the same time. Went over to see him and realized he was streaming NRL rugby across the betting operators in the very, very early days of what then became IMG Arena. And so, a lot of the work I did at the time was help start to professionalize that, and it built into the business it's in today. And when I moved to ATP Media, I turned what basically started off as, I kid you not, a plastic bag full of USB sticks, where I discovered all of the historic Hawkeye data was being stored, into something that ultimately then became Tennis Data Innovations that we see here today. So various touch points in all of that. And today, really, in my role at AWS, I'm a sports industry specialist. So basically, my job is to be that interface between leagues, federations, governing bodies, broadcasters, service providers, software vendors who build on top of AWS, to try and help really smooth and create a frictionless path to success for the whole business, not just the technology, of how we move into the cloud. From an AWS perspective, there are a lot of businesses that are built on top of AWS, right? AWS is, in effect, the infrastructure. A lot of people ask, what is it AWS really does? In effect, we are the infrastructure that everybody's businesses run on top of, be it storage, compute, network, but also a whole range of microservices that can be used for various reasons that either startups might use to build on top of, or existing businesses like yourselves with teams can actually use and create different operating models and services on top of. And so that list there is just one of many of betting-related businesses that are sat on top of AWS, and within which there are various types of things that are currently being done. Now, whether those are in terms of tracking, in terms of responsible gaming, or generation of content. We've just been hearing some interesting points on that fact. And then areas in fraud detection and personalisation, which are all built on top of various components that AWS has developed over many years. So, in some respects, it can get even wider than that, because from an AWS perspective, it also has aspects of it that can be used for geospatial offerings. So understanding where people are within the realms of the event space that you've got, and tracking them through that place. That could be for safety just as much as understanding from a retail perspective what people are doing, and also from a rights perspective. If you have a rights ring fence service, like when we did some of this work in tennis, the ticket holders within Indian Wells, for instance, were able to watch all of the match content from all of the other courts that they weren't in currently, so that they could keep on top of what else was happening around in the 20 or so courts that were there on the day that they were there. The minute they stepped outside of the event and went down the road and back home, they lost access to all of that live content. So also, things like Amazon Just Walk Out. I don't know if you've seen it. There are some places in London where you can go, but these are fixed camera rigs which are in retail areas, used very heavily in the American, US markets for sports, where you can literally just go into an area where there are fridges, grab your beer and walk out. But you're actually being captured and tracked, and your card is being charged the minute you go away, and it'll know how many beers you've got or whatever else you've grabbed at the time. There's a Sainsbury's in High Holborn that is completely configured in this way, so you can go and get your lunch or whatever you want for your evening dinner, and it works on the same basis. But the idea is it speeds up the retail aspects of when people are on site at events. Similarly with Amazon One, palm-based authentication and access control used in certain areas for media accreditation type things, but also in terms of retail transactions. Obviously, sitting underneath all of this, and we've heard a lot about computer vision in general, but computer vision sits there. We have recognition, which sits there as a service, and that can be used for a whole host of different things. But in certain cases, obviously, it can be used very much for combating identity fraud too, in the run day-to-day of your businesses. So, from the betting and gaming perspective, there are also large areas in terms of what these microservices can do to help in personalization, whether it's pinpoint for multi-channel marketing. So this is all about getting fast messaging out and personalized messaging. So these are all down through to recommendations, and also then the capability of building things yourself, right? Because if you're not a huge coding base and have tons of developers, then trying to lower the barrier for that in terms of how systems like Q Developer can work. And there's a whole bunch of services that sit in and around that Amazon Q world. SageMaker as well, from a machine learning perspective, is a very old version of what we might call generative AI nowadays, but in the machine learning world, it's still absolutely very relevant for training specific models on specific types of content that you might have. Now, SageMaker, for instance, was used a little while ago for a little project that was done with Sport Radar, in fact. And that was just to try and use the incoming event data, but also the computer vision running on the Camera One coverage of a match. And its job was to basically try and understand the momentum and excitement of the match and swing it towards an understanding of match intensity, which could lead to the idea of prediction that a goal was going to be scored. So if I play that, you'll start to see that as the attack starts to take place, the intensity starts to grow, but as the defense starts to get the better of the attack, then it starts to drop off again. And this is actually reading in real time using the computer vision. And as you can see how this attack starts to go, the likelihood of a goal starts to climb, but the unsuccessful goal means then the intensity and the likelihood of a goal starts to drop off again. However, with referees playing a part or not, you'll start to see then that as the cross swings across, then the intensity has grown to the point that actually there is a goal. And so you can see here that there are areas where it thought a goal might occur, and there was an area where it did occur. Now, obviously, that model isn't good enough to do a real predictive basis of here is a goal or a goal is super likely. But it's the start of the learning process of understanding how we can build models around based on what the live pictures are telling us and how fast we can actually turn that information around into something predictive. What I felt when I was in tennis was going to be a greater help towards us all understanding what was happening in matches was biometric data. So if I sort of rewind a little bit and take you back into that period, the thinking that I had at that time was that to hit a certain areas of the Holy Grail, that ultimately we could get, biometric data to help us with performance tracking, enhancement, very importantly, injury prevention and rehabilitation, leaning towards where fan engagement can be brought into this, and obviously from the perspective of betting and integrity, use these tools to help us understand both sides of the story in that betting world. Also, biometric is very clearly, obviously needed in terms of security and access control. We already have fingerprint authentication on our phones and things like that, but how that can be also used in general in our world that we have within sport. Now, the must-haves that kind of come with this are we need to be, if we're going to start using biometric sensors, we cannot be tied into one individual sensor. So a lot of the work that I wanted to do in tennis was to move away from saying, okay, we're going to do this and it is one sensor. it had to be agnostic to all sensors. There were various reasons why that might be the case. Players and agents particularly is another thing. I want my player to wear this sensor. We have a commercial deal, and that's why this player needs to wear that sensor. Or there are other reasons from a federation perspective in terms of the other tennis federations that were working jointly across the whole tour. So all sensors had to be agnostic. We needed to get into an area where not only it was wide area reception capable, but it was also capable of working in real time in RF hostile environments. So tons and tons of people, loads and loads of RF cameras, walkie-talkies, point of sale devices, you name it. And so understanding whether we could start to get those kind of things and get consistent, reliable data off of these devices in a competition environment. So it needed to be fast and it needed to be robust because sport involves all of those things: impact, sweat, and movement. And a lot of the sensors that I was looking at in the early days didn't really, because they were the medical grade sensors that we were testing with at the time were based on usage in medical research environments where patients, all right, they did sort of squirm around a little bit, but they were generally speaking lying down in bed, for instance, and so nothing near the movement and performance that we would expect in elite athletes. The other important thing, obviously, if we're going to have data, it needs to sync with video at some point, so we need to be bearing that in mind. At the time, I was using two different devices. You can see the size of these. Now, devices have changed considerably over time. This was back in 2017, and at the time, these were the smallest and most efficient systems on the market at the time. The MC10 there was a particularly interesting one for me at the time, because not only, as you might expect, did it do heart rate, ECG, but it also did EMG, so that's the muscle movement. And so from a tennis perspective, understanding at what point muscles moved versus, for instance, the ball being served over the net. And also it's got a built-in accelerometer and was very small. I wore it myself. It's literally the size of a sticking plaster. You can see by the 20p piece that's up there. Very thin, very lightweight, and able to stick and stay stuck in sweaty, moving conditions. So the other one here was a respiratory sensor, a very early version of it. And these things have changed a lot, but it gave me the idea that this is really something that was starting to come of age and become a real potential for us in what we were doing in sport. Now, there are challenges, right? I mean, not all sensors are medical grade. Who's got a watch on today that does heart rate? I got one. Everyone? Probably everybody's got some kind of watch on with heart rate on. I bet if we all swap watches and we looked before we did, we'd get a different heart rate from the other watch that we did if it was from a different manufacturer. There are little or no standards or classification for sensors, right? That is something that's starting to change, but in the very early days of doing this, all sensors were built to all different sorts of manufacturing standards, and there was no single point of truth for this. So for a lot of sensors, you had a relative measurement of how much faster my heart was going from when it was before, but what you don't have is an empirical version and a singular point of truth that these sensors are giving us in terms of standards and classifications. There is a lot of work now happening to try and change this because it's been identified as a real issue. And plus, as I said, we have to be mindful there are some sensors that are going to be used are simply going to be used because they're being driven by commercial sponsorship deals. Also, more importantly for all of us, the security level, the levels of security that are built into these sensors and at the point of transmission, what they're transmitting and how they're doing it has to be called into question. Because if the security from sensor back to receiver is poor, then that's going to jeopardize a lot of the world that you guys sit in particularly. So I did this work initially with a company called Sports Data Labs, built on AWS. And their aim was to try and be the aggregation point of all of these multitude of sensors, to take sensor data and then start to bring that data together to bring outcome-based predictions. Now, we started to do this work in tennis, but it really accelerated for Sports Data Labs in squash. And you heard earlier today from the legal perspective that obviously when we start to go down this road of biometric or human data, as we would call it, we're getting into the world of personal data, personally identifiable data as well. But the interesting thing with squash was all the players, because of the mood overall in the Professional Squash Association, was that they wanted to elevate the league and the competition in terms of its global appeal. All of the players signed up to doing this because they saw the benefits of how that data could be used from a broadcast perspective, but also how that data could be used ultimately in two other areas of commercial activity. One, anonymized human data for where the marketplace is now steadily growing, and two, in terms of how they would be used for themselves, for their own performance, and also obviously on towards betting in terms of improved betting opportunities. So a study was done at the time, and a whole bunch of the standard statistical data was taken, and also the biometric data of a number of different tournaments across a period of time. Male and female athletes were involved. And that health data that had really never been collected before was then combined, and this map of responses was created to create this contextual data to actually understand whether there was a capability of a predictive outcome of every single point that was being played in the squash tournaments. And these were the results. I'll zoom in a bit tighter so you can see it. But the standard bar was about at 62% based on the ball tracking data and the player data and the standard data, if you like, that you would normally expect to get out of an event like this. But when you added on the new biometric data and the human data on top, the predictive outcome for every single point was greater than 80%, which is quite a big leap. And this continues to grow now in terms of the capabilities, the understanding of the algorithms around each particular sport, and is a big area of interest for a lot of people, because going from 62% predictive capability to 80% predictive capability changes the dynamic of this and starts to make a really compelling case as to how this can be potentially used. So I'm going to pivot slightly away from this, but data is data. But if we don't use it properly, then we're kind of doing ourselves some harm. And I think we've spoken today very much about the generative AI topic, and I thought I'd just cover a little bit about how that works sort of within AWS as well. AWS has a product called Bedrock, right? That is not a large language model. For all of us in the room, when we start to think about generative AI, we start to think about, well, we're asking questions of a large language model and it comes back and gives us an answer. Now that's all well and good. I could do this in a pub. I could go to a pub late tonight, and then I could stand on a chair and I could ask everyone in the pub in the loudest voice possibly to give me the answer to a question that I might give them. And the answers I'll get back will be many and varied, I'm sure. And there might be some level of consensus, and that might be the one ultimately I might go with. But there's going to be some noise in the room, right? And in effect, a large language model, we've just been hearing about how those bots scrape the whole of everything to try and bring all the information together. But we have to be mindful that that's kind of what you're doing when you're using a generalist large language model for your queries. And so from an AWS perspective, the idea of having Bedrock was you're effectively using a singular broker that sits across any and all large language models that you wish to choose. So there are basically none of them are owned by AWS themselves, but whether you've got Claude, you've got Anthropic, you've got many of the world's leading large language models sit underneath Bedrock. And Bedrock is effectively the broker. You go to Bedrock and you use it to ask the questions to whichever large language model that you've decided you want to use. And you could use multiple ones. The important thing about that, though, is what Bedrock has is a number of advantages. A single API, so you're only really querying one thing at a time. And there are guardrails employed. So you can actually create, using tick boxes, it's very easy to do, guardrails that suggest, I want no profanity in my answers. I don't want this, I don't want that, right? These guardrails are going to be important because especially if you are thinking about presenting the answers to your questions to the outside world, then you need to be sure that you have some level of governance, and that's sort of built into this service as well. After that, ultimately, you can then do what you want to do, right? And do it in a way that's efficient and fast, because doing this quickly and using things like Amazon Q to sit on top of it gives you a quick and easy way to actually get up and running and started, but with safety nets all around you, if you like, and the comfort, if you like, that AWS is helping looking after this for you. So what is generative AI really good at? Well, in my opinion, and we've talked about, you know, we all see it, it makes pictures and stuff, and we all get a bit worried about that and where the pictures came from. I think for me, as a sort of CTO type person and someone who has worked practically and operationally, I really need to try and use stuff, right? I need stuff that all the people that I help in my day-to-day life are going to actually do things. So what does it do kind of really, really well? What it really does is it's really good at writing queries. Now, I don't know if you guys are any good at it, but writing a query for a database isn't necessarily the easiest thing to do. If you're a data scientist, it's pretty straightforward. For the general layperson, it's pretty hard work, right? And no one really needs to be taxed like that. And so one of the great things that generative AI gives us is the capability that we can use a natural language question, the kind of question you would ask me or you would ask at home, and it will write the kind of query that a data scientist would write to then talk to that database, to then talk to that data set. And that's the important thing. It's sitting there and it's just going to write the query for you. You ask it a nice, normal human question and it'll do the hard sciencey work. So it's really good at that. It's also really good at summarizing data. You can present it a ton of data. It's quite interesting. We were talking about some of the legal things. Some of the interesting stuff that people are doing at the moment is you're taking sort of case history and law, and if you're not as talented as our legal friends here in the room, you just need to have an understanding of a summary of exactly kind of what happened. And so asking it to actually look at a text or a document and give me this, a summary of it, within reasonable grounds, you would actually get a more concatenated version of that, to at least help you start to get the bones of understanding of it. I've seen this happen actually with some people in legal proceedings as they're happening, and just trying to keep on top of what's going on, because there's so much going on in legal proceedings and back references to past case history, that you're trying to actually understand, well, what happened in that case law to that extent that it becomes material for me as a layman sitting in a legal environment trying to keep up to speed. Also, what it's great at in summarizing data, therefore, is looking through reams and reams of results data and things like that to try and help you. And in general, it's really useful at working in these natural language. And the language could be any language. That's the other good thing about it, right? So this is the problem, though. We're now going to ask lots and lots of questions in an easy way and get it to summarize stuff. But what we're actually pointing it at is data, right? And if that data isn't good, data in, bad data in equals bad data out. And this goes back to the hallucination point that was before. If you have multiple data sets, if you have tracking data from one data source, speed data from another data source, results data coming from any number of different things, whether it's your event name, the racecourse name, the horse and rider's name spelt differently, any number of areas where the data is conflicting or different, then the data sets that are being queried all at the same time are going to now start to give interesting and conflicting advice. So one of the big things I talk to the leagues and federations before they jump wholeheartedly into the world of generative AI, do some housekeeping. Make sure your data sets are aligned where they should be aligned. Now that could take a little bit of work, and there are some tools available to help do that, but it is well worth doing. So before you jump in and throw Gen AI at all your data sources versus the wild west of the internet and the local pub, find a way to go through and make sure all of your data sets are clean and worthy of analysis in that respect. So let's move on to personalisation. This is becoming obviously a massive area for all of us, and from a personalisation perspective, there are a number of different use cases. I'm going to focus on the Bundesliga. DFL have the Bundesliga in Germany, and for them, they are very keen as a AWS marketing partner. So AWS has a marketing relationship with DFL to just help talk about all of the sports-related projects that go on. Similarly, there's a marketing relationship with Formula One and NFL and NHL. But this one in particular is quite interesting because DFL set their sights as being the most digital of all sports leagues, and so they're very keen to understand and utilize the data that they've got, because they have that complete vertical, like they own their own rights, they sell their own rights, they do their own host production, they do their own distribution. Just like ATP Media, where I used to work, you've got the full cradle to grave of everything, and it helps you enormously when you come to start to do this. And so their understanding of their fan was going to be key and important to them, and how also international markets could then start to be affected by it. Now, this is a technical gobbledygook diagram, and I'm not expecting anybody to really understand it, but it sort of understands from a perspective of AWS, these are all little component bits, right? You join them together like bits of Lego, and then you can end up with something. Now, whether you build it yourself, you get someone else to build it for you. AWS ProServe could also do that and build it for you. Or you buy a partner who's already built it, and then it runs already. These kind of tools are there and available. And so what this could do, for instance, in terms of the personalization, this was built and optimized to be a high-speed messaging and personalization platform that was able to deliver recommendations and messaging in super quick time, but also because it's built on scalable technology within AWS, because they're not running on your servers, they're running serverless in a way that basically means that this can just keep scaling up and down according to your demands. The auto-scaling element is super important, especially when we're in that world of live sport. Now, as I said, from Bundesliga, pushing the envelope of what they do domestically is one thing, but obviously the bigger dollars are available ultimately internationally. And so driving Bundesliga's popularity into international markets was a key objective for Bundesliga in this case. And so what we looked to do with them was to start to see whether we could generate automated commentary for these football matches that were happening live. So you take your data. In this case, these were human data loggers that were there on site, so there was no computer vision at the front end in this particular case. But those data feeds were coming in and were hitting models that sat in and around generative AI and an ML learning model underneath it, that then was able to then push out different language commentaries in real time. And not just in different languages, but we also did an experiment to see if we could also therefore create a more sort of social media kind of voice as well, which at the time they called it the bro voice, but you get the gist. But as the match played, basically, all of the event data that was coming in triggered a natural language output across different languages. As you can see, there's casual US English, the casual bro as they called it, and then in German too. But they were all being fed out concurrently as the match went on, and any event that happened was automatically pushed. And this was also taken when the Bundesliga went on Japan this last summer, and it was actually fed in Japanese natural language straight into people who were there at the match, and went down very well in that respect. And if you look at the overall side of it, this has then started to become the approach that the Bundesliga are driving through with DFL into all of their different products, apps, and also in towards what they use internally as well. So from our perspective, this is just the beginning, right? As we said, summarizing from text is now super easy. It can, as we talked about before, using RAG, having generative AI pointed at your own data sets, and those data sets are not used to actually develop large language models that are there on the outside world. So everything stays yours and stays private. And so that's the important thing, that your outcomes and your models are then built around your data sets. You can use large language models from the outside world if you want, but you can use a combination of the two effectively to try and pull the best out of your specific data, which stops some of that kind of hallucination type world. Similarly with audio, you can do two things: analyze the audio that's coming in, or actually start to create audio on the output effectively. Now, you know, traditionally this has always been a bit interesting because it's been a bit robotic and basically based from text to speech, as we know. And then obviously the visual asset side of generative AI, which we've been using in a number of areas. Super slow-mo. So you've got, in terms of camera feeds, you've got your super slow cameras, which are running at 6 times or 8 times. But sometimes there's a shot that you would actually like to see in slow-mo that hasn't had that high-speed capture in the first place. But now with the generative AI, it can actually understand and build those individual frames. And there's some really compelling, interesting uses of that. Obviously, you can't use it for adjudication. I wouldn't recommend that because these are made-up frames. But they're actually made-up frames from real frames. They're just filling in the gaps to make it flow and be smooth. And it's great, therefore, for social media and for marketing perspectives. Similarly, then, obviously, content restoration and scaling up from historic archive content. But I'll leave you with one thing in the audio side of things, because I did say you can get robotic stuff and it's not so great. But if you take all of those data pieces that we're talking about and you now want to actually expand that out to new and international markets, then the limitation for all of us is how we can wrap foreign language commentary across all of these outputs. Now we're able to generate them. And so that sort of missing area is that last bit where we can actually generate a realistic human voice that actually has the right intonation as a sports event goes on. And there's a partner of ours at IBC that's just recently happened that has done a version of this. They're called Spolk. They're known for remote commentary solutions so that you can do commentary from anywhere in the world on something else that's happening. But if I play this for you, you'll start to see.
But unfortunately, Lionel Bernier won't be joining them out there. He's unable to take part in this one. With 27
So this is a human language, a human voice, but not a human voice. It's a sampled voice of a real motorsport commentator who has given his permission for Spolk to use it. There is now a licensing model for that commentator to effectively license his voice into this model, and the commentator gets paid every time it gets used on real motorsport. And so the model is now there that true sports commentators can get license fees from multiple more matches and games and races that they could ever have done. But you'll see in a second, also sampled is another commentator for German language.
Die Startaufstellung für das zweite Rennen zu begeben, mit Ausnahme von Lionel Bernier, der leider nicht teilnehmen kann.
So the commentary is completely synthesized from the data that is sitting around this live thing, but it's drawing on the voices that has been sampled of this particular German commentator.
Zum Alpinarkurs geht. Am Wochenende vom 2. bis 4. August. Das ist also die Startaufstellung. Norbert Michlis von Marcin Croix, Raphael Suzuki und Raphael Reis auf den Positionen 3 und 4. Von Platz 5 starten Ted Bjork und Bebu Girolamo.
So Dankeschön. It's really, I think that sort of captures it all from what I have to say today. Obviously, if you've got any questions, but I think the progress of this is the most exciting bit for me. Obviously, we need to understand how and when and where to use these tools that are available to us. And certainly from us in AWS perspective, and my role is to help to lend guidance into these things too, so that lessons are learned from everyone who's in our space within sport, but we can then get the best out of these tools. So thank you very much. And any questions?
Hi there, just a quick question on that Spolk part at the end. You were saying that it was based on the actual results as it was going, but is it adding the personality of that person as well? So it's taking snippets from their previous commentary as well to add sort of a bit of I don't know, maybe the jokes that commentator might say. Is that what you're saying, or is
I mean,
it just based on the images?
Yeah, I mean, I don't. It's not at the stage at the moment where it could add in humour based on what that commentator might have said in a humorous sense. But what it's trying to do is at least bring intonation and excitement into it, but with a familiar voice. So the original voice is sampled, but the data is driving it. A bit like when you saw on that football one, you could see the excitement graph, and in terms of the likelihood of a goal being scored, using those elements of the data to say you need to talk in an exciting way now, and you don't need to talk in an exciting way here. So that's sort of how it works at the moment.
I was just wondering, in terms of the actual sporting businesses, the football teams, or how much of an issue sharing the data had been. Because from my experience in horse racing, some of the bigger organisations are sort of keen to say keep the secret sauce to themselves on their horses and on their information. And I was wondering how much that had been a challenge for you versus obviously dealing with the governing bodies who might be interested in sharing all the data. So when AWS works with data, we don't touch the data. The data is the customer's data, and we don't have any of it. It's one of the biggest tenets. I mean, you join AWS, Security 101, customers' data is everything, and customer data security is utterly primary. So AWS never has its hands on the data. There are, in terms of how data is protected, once you're set up and your own databases, your own data silos, and your own infrastructure that you've got your security on, that's one thing. But you raise an interesting point as to, is there any advantage that data could be shared across into either other sports or into within the same league, for instance, just within teams? And I think this is being dealt with on very much a case-by-case basis, where some sports are really, or leagues that are in the belief that actually by sharing the data, actually the overall sport will grow because performance grows, injury prevention grows, understanding of, even to the thing, for instance, if you look at turf, understanding turf, and because there are so many different types of turf nowadays, artificial turf and grass, can anything be learned in terms of player health and safety, lower leg injuries, and even, collision type injuries if you hit the deck hard enough? Can we draw data from the turf, and can we test the turf in every situation to try and build a database up and understanding of it? And there is a good argument, I would say, to start to think about how that could be shared. But that tends to be right up at the top of the sort of federation or the player governing body area as well. So you'll see, Sports Data Labs have done a lot of work with FIFA Pro. And so, right at that very top echelon of football are the players themselves interested in understanding this and sharing that data within their world, if you like. There's other interesting version of sharing, and that's called anonymized data. And this is where there's an interesting market play for a lot of sports that are starting to attract attention, and that is the sale and use of anonymized data of elite athletes into the medical and insurance sectors to actually grow an understanding. Because if you understand how an elite athlete lives, breathes, and moves, then that anonymized data, you can't identify it with Shane's, whose data you've got, but that could be used to help understand the wider world of either amateur sport and athletics type events, or just in general healthcare purposes. So where is the bar for a really super healthy person in that respect? So it's an interesting area, I think, going forward as to how anonymized human data could be used in that respect as a revenue source for leagues and federations and athletes themselves, obviously, because it's their data.